But let me get started so that we're efficient with everybody's time. Welcome, everyone, and those that are returnees to our Y&How sustainability workshops. We're really excited to see you here in the new year and hope you've set up some interesting goals and resolutions about living a greener life. And so we thought this would be an excellent way to kick off the new year, since many of us are thinking about what lies in the year ahead. So today we have Alisha Lopez from the Clean Cities Coalition Director, located in Broward County at the South Florida Regional Planning Council. And she's going to talk to us about getting up to speed on EV automobiles. For some of us that may just be wanting to stick our toe in the water on that, but find it a little daunting, like it's a whole new vocabulary to learn. And you can't just go in and buy a car. You have to like learn stuff before. So we thought this would be an appropriate way to kick off the new year. For those of us, or those of you who aren't familiar with Growing Climate Solutions, just a brief overview. Growing Climate Solutions is a creature or a child of the Community Foundation of Collier County, Collaboratory, Gulf Coast University, Florida Gulf Coast, and the Conservancy. Our goal has been to build awareness of climate issues in Southwest Florida, use that platform to protect natural assets, and empower Southwest Floridians to engage on climate solutions and issues. We want to increase the visibility of good solutions and create them as a model, and also have the whole community understand the relationship between climate and advancing a healthy, prosperous, and resilient region. And we do that through education programs like today. We have done some work with different partners on projects. We send out newsletters and communication through our electronic media and our social media to continue pushing this message forward. The Y&How workshops were created last year, so this is our second year. And the goal was to give our stakeholders and our participants actionable ideas. Sometimes we bring in, professors and theoreticians, and you walk away with a really profound understanding, but like, what do you do with that? So these workshops were supposed to be sort of roll up your sleeves, real practical hands-on stuff that you can use tomorrow. They're very topic specific. So today is electric vehicles, and where possible, very locally focused. We do have now a library of the recordings. And if you're willing to listen to my intro over and over again, you can go and learn about how to plant food in your garden, how to compost, how to recycle right. We have a variety of different things. Just go to the Growing Climate Solutions website, look under our resource page, and you'll see Y&How. When you're bored or have insomnia, put on those earphones and listen to some sustainability education. We have a bunch of upcoming programs. First, for those of you who haven't yet heard about the Southwest Florida Climate and Community Initiative, we're having our big summit event on January 17th at the Arthrex Center. It's a $25 admission, starts at 8:30, ends at 2:30 in the afternoon. Really interesting speakers, some roundtable discussions where you can bring your own ideas to the table. So we encourage everyone who hasn't heard about it to go to SWFL Climate, Southwest Florida Climate.org, and register for that. And then after that event, we're going to continue our Y&How series. In February, we have my friend Holly Lichtenfeld talking about what the Inflation Reduction Act will mean. In March, we have a specialist on solar and the solar co-op that's being launched. And at the end, we'll finish it off with reducing food waste. So put those dates on the calendar. We always do these the first Wednesday of the month, now at noon. And for those that aren't familiar with Zoom, very few of you these days, this is a workshop format, not webinar. So please put yourself on mute during most of the presentation. We can hear your dog bark and the argument you're having with your spouse. Please try to stay on mute and keep your camera off if there are distractions. We do want to encourage dialogue. It is a workshop. So let Alisha educate you for the first half, and then let's ask some very good questions in the second half. And that, without further ado, let me introduce our speaker, Alisha Lopez, who is Director of the the Clean City Coalition at South Florida Regional Planning Council. She is also currently on the board of Drive Electric Florida. Before joining SFRPC, she worked in private industry for almost a decade, but she's a born and raised Floridian, currently living in Hallandale Beach and a graduate of UCF with a degree in political science. Her research at that time in her life focused on the impacts of weakening water restrictions and educational budgets, but she has moved to the clean energy and electric space. And without further ado, let me introduce Alisha and let her take the screen.
Thank you so much, Anna. Hold on one second. Let me go ahead and share my screen. Are you able to see my screen now? Perfect. Again, thank you so much, Anna, for the introduction. Hello, everyone. My name is Alisha Lopez, and I'm the Clean Cities Director for the Southeast Florida Clean Cities Coalition. And the region that I cover is Palm Beach all the way down to Key West. And we are housed at the South Florida Regional Planning Council, which is located in Hollywood, Florida. And just a little brief agenda. So the presentation that I'm going to be going over will have some basics about electric vehicles, electricity as a fuel, the basics of electric vehicles, the infrastructure, and any other considerations that you may want to think about when either purchasing an electric vehicle. Okay, so let's go ahead and get into the meat and potatoes. So like I said, we're mainly focused on electric vehicles today, which includes both all electric vehicles and plug-in hybrid electric vehicles. And electric vehicles, there is an acronym, we call them EVs. Plug-in hybrid electrics, we call them PHEVs. And then there's also hybrid electric vehicles, which are HEVs. So all electric vehicles, like the popular vehicle, may be powered by the battery, which is the Chevy Bolt right here in the right lower corner, and the internal combustion engine, or a combination of both. Another type of electric vehicle we'll touch is the Chevy Bolt, which uses a battery storage energy that powers the motor. So all electric vehicles only use electricity as a power. There's no other source of fuel. You may also hear all electric vehicles referred to as battery electric vehicles, as their batteries are charged by plugging the vehicle into an electric power source. Now, PHEVs, which are plug-in hybrid electric vehicles, like the Ford C-Max, uses batteries to power an electric motor. They also use another fuel, such as gasoline or diesel, to power an internal combustion engine. As their name implies, PHEVs can be plugged in to charge the battery. Depending on the PHEV, at any point in time, briefly in the hybrid at any point in time, you would have to plug in. Most of the PHEVs you can charge at home. And then, and HEVs, which is the hybrid electric vehicle, those are also powered by an internal combustion engine and an electric motor that uses energy stored in a battery. HEVs are fueled with gasoline to operate the internal combustion engine, and their batteries are charged through regenerative braking, not by plugging in. Okay, now electricity as a fuel source. Electricity is considered an alternative fuel under the Energy Policy Act of 1992. This means the vehicles are regulated through the EPA Act and specifications requiring them to acquire alternative fuel vehicles or employ other petroleum reducing strategies. As mentioned, EVs store electricity in batteries to power one or more electric motors. These batteries are charged primarily by plugging into off-board sources of electricity, which can be produced from a variety of energy sources. EVs also use electricity created through regenerative braking, and PHEVs are supplemented by the internal combustion engine. In 2020 alone, the Clean Cities Coalition Network achieved an energy use impact of nearly 38 million gasoline gallon equivalents through the use of EVs, with another 35 million of gasoline with GGEs through the hybrid electric vehicles. So far within the market, within the last couple of years, we have greatly reduced our emissions and gasoline gallon equivalents by using electric vehicles. Let's get into some benefits, some smart grids and renewables. So smart grids allow for two-way communication between the utility and its customers, as well as sensing along transmission lines through smart meters, smart appliances, renewable energy resources, and energy efficient resources. Smart grids can help protect infrastructure from any negative impacts, from increased vehicle damage for electricity, because they promote charging during off-peak times and reduce costs to utilities, grid operators, and consumers. Smart charging invites synergies between EVs and distributed sources of renewable energy. For example, in the picture that is right here is a small scale renewable like solar panels on a rooftop. They can provide clean energy for vehicles and reduce demand on infrastructure by generating electricity near the point of use. Utilities, vehicle manufacturers, charging equipment manufacturers, and researchers are working to ensure that EVs are smoothly integrated into the U.S. electricity infrastructure. Some utilities offer lower rates at off-peak times to encourage vehicle charging when demand is lowest. Now, I know in our area in South Florida, we have Florida Power and Light, FPL, that is our main utility. And they do have a FPL evolution program that is more of a subscription service that I'm aware of. Vehicles and many types of charging equipment can be programmed to delay charging to off-peak times. Smart models are even capable of communicating with the grid, load aggregators, or facility and homeowners, enabling them to charge automatically when electricity demand and prices are best, for example, when they're the lowest or aligned with renewable generation. Get into some benefits. So EVs offer opportunities to help lower fuel costs, reduce emissions, and contribute to energy security. So for the fuel economy costs, EVs can reduce fuel costs dramatically because of the high efficiency of electric drive components. Because EVs rely in whole or in part on electric power, their fuel economy is measured differently than that of a conventional vehicle. You will likely see common metrics like miles per gallon or gasoline equivalent and kilowatt hours per 100 miles. And depending on how you drive them, today's light duty EVs can exceed 100 miles per gallon and can drive 100 miles consuming only 25 to 40 kilowatt hours. Now, tailpipe emissions. EVs produce zero tailpipe emissions, and PHEVs produce no tailpipe emissions when in all electric mode. The life cycle emissions of your EV or PHEV depend on the sources of electricity used to charge it, which of course can vary by region. In areas that use relatively low polluting energy sources to produce electricity, EVs typically have a life cycle emission advantage over similar conventional vehicles running on gasoline or diesel. As I mentioned earlier, the electricity source and emissions tools, there's a electricity sources and emissions tool in the Alternative Fuel Data Center, which is a great way to understand electric vehicle emissions, which I can also provide at the end of the presentation if you like some additional tools to go ahead and search. Now for energy security. In 2021, U.S. petroleum made up 94% of domestic petroleum demand. Although imports remained an important part of the market to supply domestic demand in international markets. Overall, the transportation sector accounts for approximately 30% of total U.S. energy needs and 70% of U.S. petroleum consumption. Using more energy efficient vehicles like electric vehicles is an important part of continuing this successful trend. Now, some considerations is, let's start off with the initial calls. And although fuel costs for electric vehicles are generally lower, the pricing of the actual vehicle is significantly higher. That said, prices are supposed to be coming down rapidly as the production from the OEMs, which is the original equipment manufacturer, or the cars like Chevy, GM, once they actually start producing more vehicles, the cost of the electric vehicles will go down as there is going to be more in the marketplace. But as of right now, we're still having some OEMs that are producing vehicles, and this year and next year, we will definitely see an abundance, like from GM, like I said, Chevy has a few, Toyota, but at least be on the aware if you guys need any additional tools. Like I said, I can let you know exactly when these new vehicles will be making it to market. Now, infrastructure availability. Public charging stations are not ubiquitous as gas stations, but charging equipment manufacturers, automakers, utilities, clean cities coalitions, municipalities, and government agencies are working to expand the network of charging infrastructure. Recently, the state of Florida was approved from the U.S. Department of Transit for our NEVI plan, which is supposed to put in, I believe it's $198 million into the state of Florida for the next 4 years for EV infrastructure throughout the entire state. And that plan is actually going to be deployed by the central office in Tallahassee, Florida, at the Florida Department of Transportation. Now, batteries. So like the engines in conventional vehicles, the advanced batteries in EVs are designed for extended life, but will wear out eventually. The batteries in electric drive vehicles are generally designed to last for the expected lifetime of the vehicle. Test and simulation results from the National Renewable Energy Laboratory indicate that today's batteries may last 12 to 15 years in moderate climates and 8 to 12 years in extreme climates. Now let's get into the vehicles. So EVs use a battery to store the electrical energy that powers the motor. EV batteries are charged by plugging the vehicle into an electric power source. Electricity produced may contribute to air pollution, but EVs are considered zero-emission vehicles because their motors produce no tailpipe exhaust. Heavy-duty EVs are available, and almost every light-duty original equipment manufacturer has at least one EV model available. EVs, of course, are more expensive than traditional gasoline and diesel vehicles, but you can offset the cost by the fuel savings, the tax credits, or incentives. With improving technologies and higher numbers of EVs being manufactured, vehicle prices are coming down. Most currently available EVs have a shorter range per charge than most conventional vehicles have per tank of gas, but they typically have a driving range of 100 to over 400 miles. Now, so PHEVs use batteries to power an electric motor and use another fuel, of course, like gasoline or diesel, to power an internal combustion engine. PHEVs have battery packs large enough to drive moderate distances using only electricity, commonly referred to as the all-electric range of the vehicle. Their all-electric range is typically 15 to 50 plus miles, because some can travel nearly 90 miles on electricity alone, and all can operate solely on gasoline. PHEV batteries can be charged in several ways: by plugging in by the internal combustion engine or through regenerative braking. Now, energy storage systems such as batteries, of course, are essential for electric drive vehicles. Sorry, my screen froze. Sorry about that, everyone. Okay, most EVs use lithium-ion batteries, which are similar to batteries found in cell phones and laptop computers. In automotive markets, they are designed to last much longer. They have a high power-to-weight ratio, high energy efficiency, good high temperature performance, and low self-discharge. Some components of these batteries can also be recycled. OEMs evaluate how and where battery materials are sourced because of concerns about the environmental and social impacts of lithium mining. So if you do need any more information or like any other kind of information in regards to the mining, please also let me know. Now, nickel metal hydride batteries are widely used in HEVs and are easily recycled. Challenges with these batteries include a high self-discharge and heat generation at high temperatures, as well as hydrogen loss. Lead acid batteries can be designed to be high power and are inexpensive, safe, and reliable. They do have drawbacks though, including low specific energy and poor cold temperature performance. Ultracapacitors store energy in a polarized liquid between an electrode and electrolyte. They provide vehicles additional power during acceleration and hill climbing and help recover braking energy. As EVs become more common, the need for accessible, cost-effective battery recycling will also expand. Widespread battery recycling would keep hazardous materials from entering the waste stream, both at the end of a battery's useful life and during its production, and reduce the demand for increasing lithium extraction. Still, EVs are relatively new to the US auto market, so only a small number of them have approached the end of their useful lives. As a result, few post-consumer batteries from EVs are available, which limits the extent of battery recycling infrastructure. Sorry, most components of lithium-ion batteries can be recycled, but separating the different kinds of battery materials is a challenge for recovering high-value materials. Battery design that considers disassembly and recycling is important. Standardizing batteries, materials, and cell phone would also make recycling easier and more cost-effective. Researchers are working to develop battery recycling processes that minimize the life cycle impacts of using lithium ion and other kinds of batteries in vehicles. The U.S. Department of Energy is supporting the lithium ion battery recycling prize to find solutions for collecting, sorting, and transporting spent and discarded lithium ion batteries for recycling and materials recovery. There are also growing opportunities for EV batteries to be reused for a second life, such as the support of an electrical grid. By using a battery in a post-vehicle application, the lifetime value of the battery increases and the cost of the battery can be shared between both the primary and secondary users. This could help resolve lithium-ion battery cost barriers to the deployment of both EVs and grid-connected energy storage. More than 70 models of light-duty EVs, including PHEVs and HEVs, are available from a variety of automakers or are currently in development, as I mentioned previously. Many light-duty neighborhood electric vehicles are also available, which you can use for low-speed applications on neighborhood roads, campuses, parks, and military facilities. In 2021, 535,000 EVs were sold in the United States. Combined with the sales of HEVs, electric drive vehicles are approaching 5% of the market share. Now let's get into some infrastructure. Charging EVs requires plugging into charging infrastructure, which is classified by the rate at which the batteries are charged. Charging times vary based on how depleted your battery is, how much energy it holds, the type of battery, and the type of charging infrastructure. This table lists the various forms of infrastructure currently available. So you have the alternating current level 1, which movements of electric current that reverses or alternates direction. AC, which is normally generated and delivered by electric utility to homes and to businesses. Then you have the direct current, which is DC, movement of electric current that continuously flows in the same direction. DC is what is normally delivered through batteries and is essential to charging EVs. So level 1 chargers, if not all, will come with an AC level 1, all the EVs that require no additional charging equipment. And at one end, you can actually plug it into a standard 3-prong household plug, and the other end is a J1772 standard connector, which actually plugs into the vehicle. Now, level 2 chargers infrastructure requires installation of home charging or public charging equipment and a dedicated circuit of 20 to 100 amps, depending on the infrastructure requirements. You will see a majority of level 2 chargers available in the public, especially at a lot of government facilities. Those are usually the level 2 chargers is what they usually use. Now, next are DC fast chargers. DC fast charging systems are designed to charge an electrical vehicle battery up to 80% charge in about 20 minutes. Their rapid charge capability makes this equipment ideal for placement along heavy traffic corridors. Extreme fast chargers are capable of power outputs of up to 350 kilowatt hours and higher, and are rapidly being deployed in the United States. Most EVs on the roads today are not capable of charging at rates higher than 50 kilowatt hours. However, vehicle technology is advancing, and most new EV models will be able to charge at higher rates, enabling the use of extreme fast charging. Now, wireless or inductive chargers. Inductive charging equipment, which uses an electromagnetic field to transfer electricity to an EV without a cord, has been recently introduced commercially as an aftermarket add-on. So currently available wireless charging stations operate at power levels comparable to that of a level 2 charger. Extreme fast charging. Extreme fast chargers are capable of power outputs of up to 350 kilowatt hours and higher and are rapidly being deployed. So currently most EVs can only receive about 50 kilowatts. Most of the Tesla infrastructure that has been deployed is the DC fast charging. Unfortunately, they are proprietary, so you would have to have a Tesla to be able to use those. However, currently right now with the levy plan, as I mentioned, the funding that we will be receiving from the U.S. Department of Transportation for the state of Florida will be deploying those DC fast chargers throughout the corridors within Florida, and corridors will be more like 95. They're looking for more of the major highways, so 95, 75, I believe US 27 and a few others. Okay. While these chargers are currently available from several manufacturers, the US Department of Energy's Vehicle Technology Office is researching ways to bridge the technology gaps and implementing extreme fast charging networks in the United States. Some EV infrastructure and network providers like Electrify America are future-proofing charging stations in anticipation for larger batteries that can be charged much faster than a typical 50 kilowatt-hour DC fast charger. Okay, so now most modern charging equipment and vehicles have a standard connector and a receptacle based on the SAE J1772 standard developed by SAE International. Any vehicle with this plug receptacle should be able to use any J1772 compliant AC level 1 or AC level 2 charging infrastructure. In this chart, the level 1 photo shows a J1772 receptacle and the level 2 photo, which shows the J1772 charging handle, what it typically looks like. There are 3 types of DC fast charging systems, depending on the type of charge port and the vehicle. SAE Combined Charging System, which is CCS, CHAdeMO, and Tesla. Note that some vehicle manufacturers that previously helped develop and promote the connector announced in 2020 that they will use the CCS connector in newer models. So that said, it is not expected to affect the availability of CHAdeMO connectors in the near future. Other vehicle manufacturers use the CCS connector, also known as the J1772 combo. This connector allows drivers to use the same charge port while driving with level 1, level 2, or DC fast equipment. As seen in the DC fast photo, 2 models of charging are often available on DC fast charging infrastructures to support both CHAdeMO and CCS compatible vehicles. The standard for wireless charging is the SAE J2954, which was published in October 2020. Okay, now charging at home. Many EV owners charge their vehicles at home overnight. For this reason, level 1 outlets, which is 120 volt, and level 2 charging infrastructure, which is 240 volts, are the primary options for homeowners. To install a level 2 charging infrastructure, a licensed electrical contractor can inform homeowners if their panel has adequate electric capacity for charging. Most people will prefer level 2 equipment for faster charging, but older homes might have inefficient electric capacity. Homeowners can always add circuits to accommodate the capacity needed for level 2 charging. Note that charging infrastructure installations must comply with local, state, and national codes and regulations, and installation requires permitting and licensed contractors. So contractors should check with their local planning department before installing any type of equipment. Before buying equipment and electric service, homeowners should check EV manufacturer guidance for information on the required charging equipment and specifications. Now, charging in public. For fleet drivers and consumers to charge their EVs in public, charging stations should be placed with daily commutes and typical driving habits in mind. Public charging stations increase the useful range of EVs and reduce the amount of fuel consumed by PHEVs. For example, being able to charge at work can double the daily feasible commuting distance for an EV driver. Depending on the situation, it can be more difficult for residents of highly density housing to find charging. Often only on-street or common garage parking is available. Still, many programs are underway to address charging issues for multifamily housing, and that is actually one of the things that I will be focusing on as well for the coalition, to see how we can help a lot of the multifamily units here within the state with EV infrastructure.
So I guess
Since Now, this picture, I wanted to give you guys just a little glimpse of all the EV infrastructure within Southwest Florida and within Southeast Florida, all the way down to the Keys. So we do have quite a bit of infrastructure with over 7,000 EVSE ports. However, due to the increased demand of electric vehicles, we are actually far behind. So with that NEVI plan and with a lot of the municipalities and counties, they're actually looking to implement more infrastructure to reduce that range anxiety for all of the citizens within our region. But I at least wanted to give you guys a glimpse to see that there is infrastructure available. And the alternative fuel data center provided by the Department of Energy has a station locator. And so if you're actually traveling, you can actually pinpoint and see exactly how far the infrastructure is, what type of infrastructure it is, if it's a level 2 or a DC fast charge, and it'll say if it's available or if it's unavailable at the moment. Okay. Maintenance and safety. So EVs typically need less maintenance than conventional vehicles. And this is all because of the battery, motor, and associated electronics require little to no regular maintenance. They have fewer fluids to change. They have regenerative braking, which significantly reduces brake wear. And there are few fewer moving parts compared to a regular gasoline or diesel vehicle. Because PHEVs and HEVs have internal combustion engines, their maintenance needs are similar to those of conventional vehicles. However, the electrical system, the battery, motor, and associated electronics will likely need minimal maintenance. Note that commercially available electric drive vehicles must meet federal motor vehicle safety standards and undergo the same vigorous safety testing as conventional vehicles sold. The exception is neighborhood electric vehicles, which are subject to less stringent standards. That's because they are typically limited to low-speed roadways specified by state and local regulations. Emergency response for electric drive vehicles is not much different from conventional vehicles. Manufacturers publish emergency response guides for their vehicles and offer training for emergency responders. Electric drive vehicles are designed with cutoff switches to isolate the battery and disable the electric system. All high voltage power lines are colored orange. If you want to learn more, the National Fire Protection Association has training and information resources available, and I can provide a one-page document that I actually received recently from them in regards to the flooding of what happened with Hurricane Ian. And last but not least, some questions that you may want to ask. What federal, state, and local incentives are available? What are your driving range needs? Are you a person that commutes more than 10 miles in a day, more than 20 miles in a day? What type of EV is best for me? Would you like an all electric? Is a hybrid electric better off? How and where my EV will be charged every day? That is definitely a key question you should be asking yourself, as if you don't have the infrastructure. And some of the housing here in Florida, yes, some are pre-Andrews, so they may have a less voltage, and you may have to have an electrical contractor increase your capabilities. Now, what level of charging you're going to need? Are there any charging stations in your area? Are they public or private? Are you able to just visit? And then I wanted to provide this one source that I think will be phenomenal for everyone if you're in the market or just looking for additional information. The Alternative Fuel Data Center, which is the AFDC, has the laws and incentive search, and then they also have the station locator. So like I said, and then another resource, if you're, let's say you do have an EV or hybrid and you're worried about your range anxiety, if you go to fueleconomy.gov, there is a trip calculator on that website, and you can actually put in where you're going to, where you're traveling from to where you're going. It gives you the amount of miles. It tells you how many times you would need to stop for an electric vehicle as well. So there are definitely tools to kind of minimize that range anxiety. And with that, I wanted to say thank you so much for your time today. I really appreciate it. And I'm going to pass it back over to Anna for any questions.
Well, thank you so much, Alisha. That was much more information than I've ever learned about EV, and very thorough. So I hope everybody can turn on their mics now and their smiling faces. And before we get totally involved, let everybody, I want to know among the people on this call, how many of us already own an electric vehicle? Can we put, let's get the hands on so we can count them up. And then we can open up the questions. So I see 1, 2, 3, me 4, 5 with Jean. I see like 5 or so. So we're at about 20% of this crew, or 25% of this crew, 6. So I don't know, that's not typically the adoption rates in the US. That is a higher adoption rate, but we're here to ask Alisha all the kinds of questions that you might have in terms of questions that you don't want to walk into the dealership and ask because, or you want to have in your back pocket when you walk in. So what was the first, what do you tell people? I'll kick it off. When people make a decision, how do they start investigating the model? Is it based on driving needs? Is it based on the look and body? What should be the first, second, and third consideration when you walk in and you're trying to make a choice?
First of all, definitely range, driving needs. To me, make and model, I know everyone wants the cars to look fabulous, even though now, the first few bodies of EVs were a little kind of clunky, but now they're starting to get a little bit better. But I believe personally, your actual driving needs. Like I said, here living in South Florida, we have people that commute from Palm Beach down to Miami just for work. So without having adequate infrastructure, they may not be able to actually purchase an EV or, with their driving needs because of that range anxiety. Even though we do have infrastructure, however, there is the off chance that sometimes that infrastructure may not work. So, and then honestly, to me, that would be the first thing as your driving needs. And then 2, for me personally, when I've been speaking with a lot of EV consumers, a really big concern is the pricing. Definitely look around and check to see what fits in your budget, because you definitely do not want to purchase something that is out of your budget. It's a little bit expensive as far as a car payment. And then last, I would say, would be kind of the look and feel. But with your driving needs as well, think of your infrastructure. Do you plan on charging at home? Does your office or wherever your employer, do they have infrastructure at your place of employment? These are definitely the biggest considerations when looking for an electric vehicle, because if you don't have infrastructure at home, where will you charge? Or if your employer doesn't, then you're going to be having to use a station locator to try to look for something. Now, Tesla has flooded the market here, especially in Florida. So their vehicles are a little bit different because their charging is proprietary. So if you do purchase a Tesla, if you do have a Tesla, you use their infrastructure. And like I said, we don't have as much information of kind of how that operates since they are proprietary. But first would be your driving needs, infrastructure, pricing, and then last, I would say, look.
Okay, do we have questions from the audience? Why don't we if everyone will put their pictures on, then we can read the body language and see who has a question. Bob, hands up first. Bob, go first.
Hi. I just put a link in the chat too for people who are looking at ways to compare easily range and price. It's a pretty cool dashboard that Bloomberg put together. But I guess, my question is a little bit more future facing. Do you have a sense of where manufacturers are with implementing two-way charging so that you could either have vehicle to home backup or potentially vehicle to grid support? I'm curious about that and thinking about the timing of my EV purchase.
I have not heard exactly yet for the two-way charging as far as from OEMs, but what I can actually do, Bob, is I can reach out to the technical response team at the Department of Energy, since they work the closest with the OEMs, and I can ask them like, hey, in regards to the two-way charging, are you guys thinking that it's going to be coming out within this year, or how are OEMs kind of operating? The one thing that I've been hearing a lot more is more so for the actual production of the vehicles more so. with supply chain issues and things of that sort. So that's kind of been the biggest topic, and kind of the most updates that we've been getting is like, hey, when are these vehicles coming to market? But I can definitely ask Bob, and if you'd like, I can provide you my contact information, so that way we can exchange information, and I can provide you, the response from the Department of Energy.
Be great. Thank you.
No problem.
Any other questions? Oh, come on, guys. Well, I'll kick one off that I asked Alisha yesterday. So I am the proud recent owner of a recharge. So just for those that aren't familiar, I get about 40 miles on a charge, pure electric, and then I seamlessly go into gas. So for most of my local driving, if you haven't, stories from the owners, right? For most of my local driving, I am on pure electric. I have purchased this car in the end of September. I have been to the gas station twice. One time because I drove to Naples and back, and of course I used up my electric. And then I needed a little bit more fuel to top it off. I put 6 gallons of gas, except for the return trip from Naples. I have put 6 gallons of gas in my car since September 28th. Most of my I am on a level 2 charger. So it takes 5 to 6 hours to charge in my garage. The cost of installing the 220 plug was about $600. I did not need to redo my panel. If you have to redo your electrical panel, estimates are $900 to $1,000, depending on your electrician. I'm just throwing out those numbers. I researched them, share with others. My question to you is, how do we manage the breaking down of infrastructure? So I took my EV to an airport and wanted to charge in the cell phone waiting lot so that I could get back on pure electric, and go to the lot to find 2 chargers, one being used and one broken. What do you do then? And how does that manage people's range anxiety? I mean, granted, I'm on a 40-mile, string, and luckily, and this is why I have hybrid, so that I could get back on gas. But how do you manage this infrastructure that's starting to age out and has to be replaced, and you don't know if it's working or not?
That's definitely a large question that a lot of stakeholders and just EV consumers ask. I know definitely on the alternative fuel data center on the station locator, they do have an area when you're looking for electric vehicles. It says whether or not they are functioning or not, and whether or not they're public or private, because that's another issue if you're not sure if that's a public or private charging. Now, the thing with servicing is it depends on where the infrastructure is. So like, for instance, municipalities usually all work with an EVSC provider like ChargePoint or even FPL. So for instance, like I know in the city of Boca Raton, they have FPL infrastructure on their city hall property. It is free for the citizens to use to charge. However, FPL actually maintenances that infrastructure. So the city of Boca is not responsible for if anything breaks down for coming out. So it really depends on what type of area it is. Like I know, for instance, there are other cities and municipalities where they actually have a contract and they service it with a provider. So for instance, like in Miami, they use Brickell Energy, and they'll come out and service the ChargePoint infrastructure to make sure that it's available. Unfortunately, like they are coming out with more real-time applications like ChargePoint if something goes wrong. And Tesla is actually really good at that, with having real-time dashboards that show if the infrastructure is not working. But honestly, this is one problem that we're all starting to kind of come to grips with. And we're speaking with a lot of the electric vehicle supply equipment people. We're talking with cities, counties, but it really does depend on the type of servicing agreement that infrastructure or that location has with the provider. But yeah, like right now, that's one of the things that we're kind of looking into to see how we can kind of keep the network robust and always ongoing, since now Florida has become second behind California with EV consumers, and we're about 8th in infrastructure. So we have a lot to catch up with infrastructure, and plus on top of that, when it doesn't work, it causes even more of a headache. And honestly, yes, it is a deterrent for some individuals to purchase an electric vehicle knowing that there is no infrastructure or it doesn't work.
Any other questions? Mark? and then Jean after Mark.
Yeah, good afternoon, everyone. I'm the proud owner of a Tesla and a PHEV. We got the PHEV because here in Naples, hurricanes sometimes knocked us completely off the grid. And we're just worried that, we'd be stuck, if we had an outage for a long, serious amount of time. In the time that I've had the Tesla on this side of the coast, Tesla has done a great job of improving their infrastructure. But for my other vehicle, it's really few and far between. And you mentioned this 4-year plan to improve generally infrastructure in Florida. Kind of what is the rate of rollout? I mean, is every year going to get 25% better? Or is this, going to be 3 years before we start seeing real results?
So I'm hoping that once the Florida Department of Transportation actually receives the funding, that they will actually implement right away. I know that they're working with a consultant on the actual plan and that they will be hiring, I believe, an actual person to implement the infrastructure all throughout the state. But the first year, yes, so the amount is split up into, like I said, those years. So each year will get a certain percentage to do the infrastructure. Now, FDOT actually has their NEVI plan online on their website, and it shows kind of the desert areas of what they kind of want to put the infrastructure in. Unfortunately, I know within this area in South Florida, they do not really have anything that they're using for the NEVI plan within the first year. And that is due to because I know the federal requirement right now is looking more so the first year with rural and underserved communities. So I believe that they're going to be moving more toward like the North and Central Florida area first to put in that infrastructure. And then, of course, it's going to trickle down. But from my understanding, that first year is going to be more rural areas since there isn't much infrastructure up in North Florida to kind of make sure that the whole state connects. So if anybody from down here wants to travel to Tallahassee, there is no range anxiety when you're traveling through 75 or other areas like that through I-10.
Jean, you're on mute. Unmute yourself. There you go.
This is a small question, but you said that battery life depended whether it was in extreme weather. I wondered if Florida is extreme weather or not.
So usually I would say no, but with our hurricanes lately, that's the part that's extreme. And honestly, one of the things, me being a native Floridian, born and raised here, that's one of my biggest concerns because I've been through many hurricanes and I know what it's like to go without power for weeks on end. That is an issue that I have addressed with the Florida Department of Transportation in regards to it, because of course, EVs are very beneficial to the environment as far as with no emissions out the tailpipe. However, us being the size of the state that we are and hurricane season 6 months out of the year, my biggest concern is what happened with Ian, people not being able to evacuate or EVs exploding because of being submerged in salt water. So I have addressed these issues with even the Department of Energy. I can provide some more additional information in regards to that. Also, I don't know if you guys were able to see, I did put the bulletin from the National Fire Protection Association in the chat that talks about the EVs and the flooding. Yes, it is unfortunate that that happened. However, from my understanding, it was a handful of vehicles. I have not heard more than 6 exploded. However, and meanwhile, gasoline vehicles, they combust every 3 minutes, I believe, from the National Fire Association. So it's just because EVs are the new thing, they're pretty, there's the new kid on the block. So whenever anything goes wrong, it makes headlines. However, how often do you see, oh, okay, this gasoline car exploded? You really don't see that anymore. So of course, there's going to be some kind of kinks, but and to answer your question, Jean, no, Florida technically is not an extreme climate state. That would be more so, I think, the Northeast, especially kind of what happened this past winter, because EVs don't necessarily function the best with extreme cold weather. We are actually in a very prime position that Florida has a phenomenal climate. Even with our mild winters, you can still use your EVs, even being in Jacksonville, Tallahassee, all the way up through the Panhandle. So, but right now, like, with the whole emergency management and hurricanes, that is what so far has been kind of like, oh, wow, what is, so, but like I said, it's extremely rare that it happens, and it only happened to 6 vehicles in the entire Southwest Florida that I've heard of. So.
Richard?
Yeah, I've only heard about golf carts going up all over the place. I have no idea what kind of battery that is.
Okay,
Maybe it's related, maybe it's not. Um, okay,
Those are lead.
hang on 1 second here. I got muted.
thank you, Tyler.
No, we're hearing you now. Now you're muted.
They have graphene batteries up in Cape Coral or something, and they're doing a retrofit for golf carts with some graphene battery chemistry that is Chinese based, but it's I mean, graphene is graphite, but China controls like 80 some odd % of the graphite in the world, so they control the graphene. But they have a really interesting application for converting golf carts into solar powered little graphene battery, and it takes off like 300 pounds of the weight of a golf cart, because those lead acid batteries are so heavy, and graphene is like, the lightest material we've ever discovered.
Right, you got people going with diesel powered golf carts. That helps. No, I was thinking before is, extreme weather to me, I think the opposite. I think of down here, batteries in my regular cars don't last 3-4 years. Up north, batteries last a lot longer. So I have a 4-year-old plug-in. So I'm wondering, am I halfway to death right now? Is this only having an 8-year lifespan? Am I depreciating rapidly? Is it time to trade in? But I have not noticed any real loss of capacity.
I was just going to say that no, as far as like some of the studies that I've read, and even speaking with EV owners here within Florida, one particular woman who lives up in the Central Florida area, she's had her Nissan Leaf since it was released. She has had no issues with her battery capacity. She has no issues charging. And like I said, she's had it, I think she told me she's already coming up to a 10-year mark. And she said she hasn't seen any type of kind of, degradation on her battery. Yeah, she absolutely loves her Leaf. And then eventually she purchased a Tesla as well for her and her husband have those 2 cars. But yeah, she said that's one, specific example that I actually have, but I have not heard of anyone saying within 4, 5, 6 years that their EV batteries have depleted. I haven't heard anything like that within the state.
They have an early depletion, and then they stay pretty stable. There's like a early depletion phase of the first recharge, and depending on how gentle you are on the recharging, if you're not just recharging all the way to 100% every time, charge to like 80. I've put 15,000 miles on my Tesla Model Y this year, and it was the best driving I've ever experienced.
Nice. No range anxiety, right, Tyler?
Not even close. I mean, you just put in where you're going and it'll take care of all the decision making for you. I've never had I'd never had to be so dumb to drive such a smart car. But it's truly, one of our subsidiaries, T4L, we've got a fleet of 32 Teslas right now. And but we're working with Porsche and Nissan and all the major OEMs. So it's been fun to accelerate the adoption of electric vehicles as transportation as a service. And I've been excited to see it grow. We incubated it while we were bored under COVID, and Tesla gave us the thumbs up. And so we have EVs in 14 states now. And so it's fun, and I love the perks.
I definitely want to talk to you offline, Tyler, about your fleet.
Yeah.
And kind of see how everything's going. Yeah, I definitely want to see.
For those of you who don't know, Tyler and Gravitas is one of Growing Climate Solutions' earliest partners, and they're up to all kinds of really exciting stuff. Go check out their website, or I'm sure Tyler would be glad to talk to you about it. But I knew he was going to be on this call. Any other questions from the audience that we have? One of the things that I, as a new EV owner, I got confused about was, when do municipalities have free charging, and what does charge point mean, and how do you get to be a user? Do you have to sign up? Like, what's the difference between the paid ones, and how do you find them, and the free ones, and how do you find them? Some people say that the municipal ones will become obsolete as the range gets longer. There'll be less of a need to roll out because the ranges are getting so much longer. But I'm
wouldn't
still a
necessarily-
novice,
I
so
was gonna say, I wouldn't necessarily agree with that. I know, because I know, for instance, here in South Florida, we do have quite a few EV infrastructure, and I'm still getting calls from municipalities about, hey, we want to put in EV infrastructure. We know about the NEVI plan. We know FDOT is putting this every 50 miles within the corridors. However, there's still desert spots for their citizens within that municipality. So for instance, like University Drive here in South Florida, there's barely any infrastructure along that entire corridor in all of Broward County. There's one or two, but there's all these desert spots. So if someone is living, let's say in Miramar, which is off of University, and they have to, let's say, travel, they want to go north on University, before they hit another infrastructure, it will be quite a while, unless they decide to go east, which is mostly by the major corridors. And if not, you would have to jump on the turnpike to use either the FPL or Tesla infrastructure. So it's the cities and municipalities, they're still going to be putting infrastructure for their constituents and their citizens. Like I said, FDOT is going to be doing along the major corridors, like the Turnpike, 75, and they'll be every 50 miles. I know FPL has a contract with the Florida Turnpike Enterprise, so they've been putting them along that corridor. However, we still have an abundance of state roads and state highways that need infrastructure. So, and like, for instance, US 1 is the only road that goes to Key West. And that is a long drive for someone in an electric vehicle. If there is no EV infrastructure along that corridor, nobody with an electric vehicle want to go down to the Keys. So that's why I say that the municipalities and even the counties, they're still going to put that effort forward to put the infrastructure, even though the state is doing, their portion of it. I know for a fact they're going to still put in infrastructure. Now, as far as the free to charge, I know that there are certain, the AFDC, I keep mentioning it because to me, that is the best tool that you can have, unless, like Tyler said, if you're in your Tesla and then you just put it in, that's a little bit easier. However, if you don't have a Tesla, definitely check out the alternative fuel data center, the station locator. I'm actually going to put the link into the chat. And on this actual website, it tells you whether or not it is available, it is public, and if it's working. So I know a lot of the municipalities want to put in some sort of free infrastructure into their area. So they've been kind of implementing that, but the way that they kind of help ease, I guess, the cost for them is they've been putting a cap on how long you can charge there. So like I know in the city of Boca, I believe they have a 2-hour maximum. And then if you're there for over 2 hours, I believe you get ticketed and fined for keeping your car there. So I know the municipalities are trying to kind of push forward for more citizens to use the electric vehicles. So I know right now they've been rolling out kind of the free charging, even in Miami-Dade County and a lot of their government facilities, it's free charging. Those are charge point units. However, they're serviced by Brickell Energy, which is a Miami-based company. So, and then the paid ones, yes, you do have to subscribe. I know ChargePoint, for instance, you can actually create a free account through any of the EVSE providers. And then once you actually get to that infrastructure, for instance, like ChargePoint, it'll tell you if that one is a charge one, and then they'll ask for your, credit information and things of that sort. But yeah, like Blink, SEMA Connect, ChargePoint, you just sign up for an account. The account's free online. It'll tell you about where the infrastructure is. And then at that point, if it is a paid one, that's when you would use your own personal kind of money to pay for that specific charger. But the AFDC to me is the best option to see whether or not it's public, if it's free, and how often it's available, because there are some that are listed on the AFDC that are private, or they may close after a certain period of time. But
Richard, we're on the top of the hour, so you have the last question or comment.
Okay, last question is about the whole mindset. Unless you have a supercharger on the highway, you're going to be there for a while. People now, we're used to what we've been doing for 100 years, get in, get out, and the time doesn't seem to be wasted because we're busy doing something. I do my emails. I mean, it's not at a convenient place for me right now. So if I'm going to go to a public charger and not come home, then I bring my work, I bring my emails, my paradigm shift on how I run my life, and it's not a problem.
I like that you said that though, Richard, because I agree with you. Like one thing, and specifically in the area that I'm in, the charging infrastructure is around restaurants, shopping centers, schools, libraries, you know, places where you're actually going to be more than 20, 30 minutes, you know, sometimes even hours. So, you know, I feel like some people are a little like, oh, it's going to take forever to pump my fuel. And it's like, no, even when you go, like, let's say you're taking a road trip down the turnpike, you stop. I have to use the restroom. Oh, you're with the kids. Okay, we have to get something to eat. Well, guess what? That's going to take at least 20 to 30 minutes just to use the restroom, get something to eat, and get back in the car. And you could be charging your vehicle at that time. So, you know, it takes, of course, everything takes getting some time to get used to. However, I don't think it should be a hindrance for people to purchase electric vehicles because you have to wait a few minutes longer just to fuel your vehicle. I see constant people doing the same thing as you, Richard, having their laptop, they're charging their car, you know, they're writing emails. Some people go get coffee. But, you know, to me, it's just, like with everything in change, it always takes a little bit to get used to, you know, like even with gasoline vehicles, we had horses. They thought people were crazy about, you know, implementing a vehicle. So, you know, everything to me is always going to take some time and some education for people. But, you know, like, it's good that people at least have questions in regards to kind of the space that we're moving to now. So.
Well, with that note, I'm going to wrap it up. Alisha, if you could just post your contact information. I hope everyone on this call will feel free to send an email, and we will also send a follow-up email with some of these resources to everybody who's been in attendance. If you know somebody who missed this, they can get the recording in about 3 or 4 days. We will get it up on the website, hopefully. And I'll make a last plug for our climate summit, which is coming up. So if you're really interested in learning about sustainability and getting engaged on solutions for our climate challenges, do sign up and attend the climate summit on January 17th. We are looking for, you know, people interested in engaging on tough questions and solutions. So please join us, and join us for the future Y&Hows. We created them in a series. So the next one, even though Alisha posted some information about which cars are eligible for which rebates, the next Y&How in February will take up that topic. What is in the Inflation Reduction Act? So spread the word, and I hope that you'll spread the word to friends that you talk to about what you've learned today, that there are opportunities for learning about climate and sustainability issues all the time. They're free, and keep spreading the word about growing climate solutions in our activities. Thank you so much, Alisha, for sharing your knowledge, and thanks everybody for coming today. Have a great day, stay safe, and may your new year